Welcome. Thank you to this conversation today about climate change with my colleagues Georges and Keys. We are going to be talking to you today about climate-related issues. I'm going to start off the talk today going through a state of the climate. My role is to describe kind of where we are today in terms of our climate understanding and what the potential future issues are. My colleague Keys will follow up with some adaptation and observational information from vineyards and viticulture worldwide. And then Georges will follow up with the situation in the Douro. So I'd like to start off by saying the state of the climate is really a challenge right now. The rate and magnitude of change is really concerning. Human influences are increasingly evident, and this is not only in fossil fuel use, but also urbanization, deforestation, desertification, and ocean acidification. Many issues impacting our environment. We have increasing weather and climate variability, as you can see from the news. It's just pretty clear. We also have record extremes occurring. I'll talk about this a little bit more as well. And then we also have drought, fires, and smoke impacting many wine regions worldwide, especially in my region here. So this is a map for global temperature departures for January through May. The June data is preliminary, but January through May was the 8th warmest on record so far globally. Preliminary data for June indicates that the month of June will be the 4th warmest globally, and the 2nd warmest in Europe, and the warmest on record in North America. Virtually certain that 2001 will end up a top 10 warmest year on record. The only thing that kept us from possibly being maybe a top 1, 2, or 3 is the fact that we've been in a fairly strong La Nina, which tends to mute temperatures somewhat. I'll talk about that in a minute. I also wanted to mention that the major agencies that monitor and depict climate over time from multiple different countries and agencies are all lining up now. Our observational evidence is much more consistent across these agencies and clearly showing where we are relative to the long-term temperature trends globally. I also wanted to mention this piece of it because I think this gets lost a little bit when we talk about the variations on climate. The El Nino, La Nina cycles influence our global temperatures to a large degree. This diagram by NOAA shows where El Nino months in red tend to be those that spike in temperatures, where La Nina months in blue tend to be somewhat muted in terms of global temperatures. What's called the ENSO neutral years or months are times in which we're not playing one way or another with El Nino, La Nina, but there's still some drive in terms of how those temperatures play out. So you can kind of see where we are right now. We've been in this La Nina, which has muted our temperatures just slightly, but we'll talk a little bit more about it because there is some indications that El Nino may be back this fall. Talk about climate extremes a little bit. First of all, there's been a major global update looking at 36,000 weather stations around the world that's looked at extremes. Extreme weather events such as heat waves and droughts and heavy rainfall are now much more frequent and more intense and longer lived than they have been historically. This is just showing warm days and the annual trend over time. Very few places have seen any decline. The vast majority of global land areas are all trending much higher and warmer days over time. I also wanted to show that how we look at some of these record levels in terms of warm or cold events, you can see from about the 1950s through 2021, that the frequency or the percent of the area, I should say, of the globe that is under either record cold or record warm is flipped. Today, we are clearly in a much greater pattern of much more of the globe being having a percent of the area in record warmth. In 2016, that number even jumped over 11% of the globe. You can also look at this data just slightly differently and look at the ratio of warm climate records to cold climate records. Back in the 1950s and 60s and 70s, we were just slightly higher percentage of cold events to warm events. But today we are just dramatically different in terms of those records, 50 times greater ratio of warm records to cold records today. So again, some extreme kind of changes that we've been observing in the system, both dynamically and statistically. Many of you have probably heard about the extreme heat that we had just experienced in the Western United States and Canada. And I just wanted to show you this in relative to some extremes. This is a long-term daily high temperature trace for Lytton, British Columbia and Canada, which set a new national record on June 29th of 49.6 degrees Celsius. And you can see how far outside the norm those observations were. And these were 4 days in a row in which temperatures were that far above normal. Same thing was happening in many places in the United States, and it's still going on right now in parts of California. Talk a little bit about some observed trends in wine regions that are out there today. We did a project a few years ago in which we looked at these 23 locations in wine regions in different places in the world, trying to get capture some information about how temperatures had trended over cool regions to warm to hot regions in different areas. Here's just 4 different trends for Perth, Napa, Burgundy, and Surrey in the south of England. All of these showed trends to warmer conditions over time. The trends are not, perfectly matching because a little bit of difference in regional location types of responses, but you can see the general nature of all this. All of these locations, all 23, warmed significantly from a statistical framework. Decadal rates average 0.12 degrees Celsius per decade. And the period of record for all of these locations averaged 1.4 degrees Celsius over all 23 regions. We also looked at precipitation, and I'm just going to give you some sense of this that I think is really interesting. First of all, across these 23 different locations, annual precipitation ranged from 200 millimeters to over 1,200 millimeters. Quite a big difference in terms of the overall amount of precipitation in each region. Growing season rainfall, just going for a 7-month period during a growing season, ranged from 60 millimeters to over 570 millimeters. That means that some places have more growing season precipitation than other places have entire annual precipitation. So some pretty big differences there. The ratio of growing season precipitation to annual goes from 14% in places like Mendoza to, 84% in places like Mendoza, and 60% or so in Burgundy and other areas, whereas other places like in Sonoma, Chile, Napa, Madeira, all have a tendency to be much lower in terms of their overall amount. Interestingly, there's very few precipitation trends, although interannual variability is high in most regions. And I think it's really important that many of our grape growing regions worldwide are in summer dry environments. And those summer dry environments are what we've become pretty concerned with, because it appears that those regions have a tendency in future climates modeling to become drier over time. So we've become hotter and drier both during the summertime. Wanted to show you a little bit about some statistical frameworks behind this. This is just a typical standard normal curve for temperature distributions over this 120 plus year record we have in my region, the Willamette Valley of Northern Oregon here. Each one of these standard deviations is approximately 1.1 degrees Celsius. If you look at the data that we have from since 1990, we've had 3 years that have been below the mean. For example, 2010 was 0.6 standard deviations below the mean for the period. However, 18 of the last 20 years have been between about 2.2 and 3 standard deviations above the mean. So we've been definitely much more, playing in this warmer tail of our distribution. 2015 was one of our warmest years, and we are currently on track right now to either be very close to 2015 or surpass it here in Oregon. So again, playing 3 standard deviations above our long-term mean. Climate change in the future, showing you some data from multiple different organizations. This one's from Berkeley Earth. They've done a very good job of pulling together data from multiple sources. And you can see what they've showed here over time, the general trend. But I think what's important here is that since about 1980, this trend, while there's been some variability year to year, it's behaved almost in a linear kind of framework. And so if you just even take a linear trend going into the future, we're looking at somewhere 1.5 degrees Celsius warming by about 2036 and 2 degrees Celsius by 2063. So very much a concern as this rate of change seems to be quite rapid. The other thing that I wanted to mention, I have 2 slides on this real quickly, is to talk about our climate modeling. Our climate modeling, since I got into this business of looking at future climates, has really gotten much better. And I'm quite amazed by how well they've performed. We have some equilibrium climate sensitivity studies that are out right now that are showing us that what the temperature increase will be when CO2 is doubled and the climate system comes into some kind of equilibrium in the future. Most studies since about 2000 have a best estimate of about 1.5 to 4.5 degrees Celsius. However, the early results from the most recent CMIP6 models are indicating this is actually likely a little bit higher. So our climate sensitivity may be more than what we've been understanding up to this point. And importantly, you can look at some of the new models in terms of how they project things in the future, with the red being fairly pessimistic in the emission scenario of 8.5, and then blue being more realistic probably, and then green being quietly optimistic. These models are the new models that are driving all of our current IPCC efforts at understanding future climates. I wanted to get back to kind of future climates and look at how some of these models are showing how places like California in their distribution in terms of their historic and projected temperatures are. And again, about 1.1 degrees Celsius per standard deviation here. In 1981 to 2010, our most recent climate normal period, California as a state was roughly 1 standard deviation above their long-term average. If you look at what was projected for 2020 to 2040, which arguably we're already in this 20-year period, we're supposed to be on average running about 2 standard deviations above average. If you look at projections for 2040 to 2060, again, looking at this outer envelope here to mid-century, we're really supposed to be just slightly less than 3 standard deviations above our long-term average in the future. However, this is something, pardon me, something I think that is a big concern. Again, many of the last 20 years or so have already been near the average of what we're projecting by 2050. I guess the question would be is that are we already at the temperatures the models are projecting? The models just aren't maybe quite sensitive enough, or are we looking at something that may be even more extreme than our models can depict at this point in time? Real quickly, a little piece of research out of California as well, but this plays out in many places like Australia and South America and parts of Europe as well. We know that extreme dry years in California in the future look to be somewhere between 2 and about 2.5 times more frequent in California than they are today. And the very big impact here is water scarcity and availability for both society and agriculture. But we also know that extreme wet years are also likely to be much more frequent, 2.5 times more frequent in the future. The key impact here is infrastructure stress. How do our water management systems and cities manage this? The result is this dry to wet whiplash kind of scenario where we're likely to be maybe 1.25 to 2 times more frequent to swing back and forth between drought and heavy rainfall years. And then that, of course, plays into this whole severe storm sequencing where most of the modeling efforts say that by the end of the century, we are likely in a 5 times more frequent severe storm return interval than we are today. And again, many of these same kind of things are happening in other places in the world. So what does the changing climate mean for a given region? This is a diagram I've worked on for quite a few years, and it just shows us where we can expect climatically in the growing season these regions to be. And I'm only going to show you an example for my region. The Willamette Valley is a relatively cool climate region, and this green box that you see here, that is its climate envelope, going from the coolest of sites at higher elevation and toward the coast to the warmer sites within the region. So this is the climate envelope for 1961 to 1990. As we've moved into our 1981 to 2010 climate normal, you can see that that entire envelope has shifted. It shifted to to a warmer, of course, and changing, the nature and the style by which we can ripen our varieties. Our 1991 to 2020 climate normal, which just came out, of course, shows us even further moving into the warmer categories here. And you can see that only the coolest of places today have swapped places with that of the warmest in the previous climate normal. Our modeling efforts going to 2040 to 2060 put this envelope, this climate envelope, out into areas in which we have never been. And it opens up possibilities for other varieties, but it also changes the nature of the Pinot Noir and Chardonnay dominated production within the Willamette Valley, because only the coolest of places will be still within what we know today as being Pinot Noir suitable. So I want to put all this into some summary and set this up for, of course, for Kees and George to talk more about these issues in terms of adaptation and in the Douro. So first of all, the planet is warmer than any other time in our recorded past. I think this is pretty clear. We also know that substantial variability in the weather climate factors that we experience are expected to continue. Persistence in the global climate system points to continued warming. And again, if you look at Berkeley Earth's data right here, this is what they projected back at the end of 2020 in the fall, early winter. The likely range for 2021 is in this kind of top 10 realm. We are currently halfway through the year, and we're definitely within this likely range that they've projected. And there's a 99% rate that will end up, probability that will end up in this range at the end of 2021. This top 10 finish for our 2021 vintage or global temperatures will be definite if the forecast for El Nino in the fall is correct. El Nino is an onset of very warm water in the Pacific, which just tends to add to the overall warmth of the atmosphere. Weather and climate extremes are also forecast to continue at or near record numbers in many, many regions in the world. When we look at wine regions, just a summary from some meta-analysis that you can look in the literature, we've seen warming of somewhere between 1 and 2.4, 2.5 degrees over the last 50 to 100 years in wine regions globally. Precipitation trends are highly variable, but they are significant in some regions and in some seasons. Grapevines have responded. Lots of phenological research has been done, and we've seen somewhere between 5 and 10 days response of earlier events with 1 degree Celsius of warming. Plus, we've also seen in some places more rapid intervals between the events. The vines are accelerating their growth. Meta-analysis of any modeling that has been done looking at wine regions, fairly conservative estimates point to 1.5 to 2.5 degrees Celsius warming by mid-century or just beyond. They also point to increasing climate variability as highly likely as well. But again, I get back to this idea. During the last 15 to 20 years, many regions worldwide have already seen some of the conditions that were expected to be more like on average by 2020. What that means for us, it really is kind of unknown now. It's possible that we're just getting there quicker than our models are anticipating. Lots of challenges here, of course. You're going to be talking about this more and more, I think, in this conference, but I just wanted to say that from a viticulture and wine production sector framework, these include how we manage and observe vine growth and productivity over time, how these changes in climate induce heat and drought stress in different regions in different ways, how changes in pest and disease occurrence and severity occur within sectors growing grapes and making wine, how ripening characteristics occur. And I know Keys will talk more about this as some adaptation possibilities, and then also wine styles, how those change as well. Water resource issues are going to become more and more evident. Of course, society has their own kind of needs for water, but agriculture does too, whether it's natural rain-fed systems that are not irrigated or irrigated systems that need to manage water. We're going to be clearly moving into more resource dependent issues. Long-term stability to commercially important varieties is really important. We've developed this industry based upon a relatively small number of commercially important varieties. And what that looks like in the future is going to be very important relative to how we adapt to climate change. And then lastly, I think, again, this idea of adaptive capacity. In an agricultural system like viticulture and wine production, we need to develop the adaptive capacity both of the plant system and the human system so that we can reduce our vulnerability as we move forward. And with that, I know that my colleagues are going to talk more about this from an adaptive standpoint from Keys, and then a very local standpoint from George. So I thank you very much for your time, and I hope you have a wonderful conference. I wish I could be there with you. Thank you very much.